Okay, so we need three assumptions. Simple. First assumption is simple random sample, and second one is normal population or large sample, and sigma is known. And we will follow this step to perform the hypothesis test. So the first step is we need to write the hypothesis, then we need to decide the significance level. That's when we need to decide the alpha value. Then we have to compute the test statistics, the Z observed or Z0. Okay, so is the quiz on Tuesday? Yeah, the quiz will be in next week, Tuesday. Yeah, that's correct. You're welcome. Okay, then step 4 is we can use either critical value approach or p-value approach to make our decision whether we'll reject the null hypothesis or we'll fail to reject. So we discussed it in the last class. And step 5 is we'll make our decision. And step 6 is we'll interpret the result based on our decision. And here is the way to use the one mean Z test. So for a small sample, the population should be normally distributed. And for moderate sample size, that's mean if the sample size is between 15 to 30, then we'll use the Z test unless the data contain outliers or far away from the normal distribution. And for large sample, that's mean if the sample size is 30 or greater than 30, we can use Z test without knowing the distribution. But however, if the data has outlier, then we'll perform the test with outlier and without outlier. And if we see different results for two different tests, then we'll consider some other test. Okay. So let's go over some example. The first one is a sample mean, and sample size and population standard deviation are provided below. So we have the sample mean, sample size, and the population standard deviation. So the sample mean X bar is 27. So we have X bar is 27. And we also have the sample size N is 32. And we have the population standard deviation is 8. So this is actually one of the assumptions. The sigma is known. That's when we know the value of sigma. And the first step is you need to write the hypothesis. So the first step is we need to write the hypothesis. So what is the hypothesis? We need to write null and alternative. So here the null is given, mu is equal 31. That's when the population mean is equal 31. We want to test whether it is actually lower than 31. So we want to test mu is less than 31. Okay, the next step is we'll decide the alpha value. So what is the alpha value here? So the level of significance. So we'll perform the hypothesis test at 1% level of significance. So that means the alpha is 1%. So here alpha is 1%. So that means alpha is 1%, which is 0.01. So this is our alpha value, level of significance. So now we need to calculate the test statistics. Step 3 is we'll calculate the test statistics. So before calculating the test statistics, you need to determine what type of test you are using here, whether you are using Z-test or t-test. So first thing is you will look at the population distribution. So we do not have any information about the population distribution. So we have just the population standard deviation, but they didn't say anything about the shape of the distribution, whether it is normal or some other distribution. So since we do not know the population distribution, we have to look at the sample size. So look at the sample size. N is equals to 32. So we can consider as a large sample, right? It is greater than 30. So the sample size is 32. That means we can use Z-test. So Z0 is equal x bar minus mu 0 sigma over square root of n. So this is the test statistics. So now I will plug in all the numbers. X bar is 27 and mu 0 is the hypothesized value. So that's mean the value in the hypothesis. Mu 0 is 31. So minus 31 divided by sigma is 8 over a square root of n, 32. So that's mean if you simplify this one, then the test statistics will be negative 2.83. So this is negative 2.83. Okay. So now in step 4, so if you use the critical value approach, then you have to find the critical value. But if you want to use the p-value approach, then you have to find the p-value. So here we'll be using the critical value approach. So we have to find the critical value. So how do we find the critical value? So to find the critical value, we need to know alpha, which is 0.01. And then the critical value is, since this is lower tail test, so if you look at the alternative hypothesis, this is less than. So that's mean this is lower tail test or left tail test. So the critical value will be then negative z alpha. And if from the z table, we can find this one, alpha is 0.01. So you will get, this is negative 2.33. This is negative 2.33. So this is the critical value. Okay, so let me see if you have any question. Yes, sure. Yeah, do you have any question? So here, first step, we wrote the null hypothesis, alternative hypothesis, then alpha is 0.01 because it is 1%. Then the sample size is 32, which we can consider as a large sample size. That's why we are using z-test. So we calculated the test statistics, which is statistic, which is negative 2.83. Okay, sure. Yeah. Okay, so alpha is 0.01, which is 1%. So this is the critical value. So we calculated the critical value. So this is CRI, critical value, because we are using critical value approach. So now in step 5, we'll make our decision. So what should be our decision in this case? So it's better to draw the normal curve. So this is our critical value, which is negative 2.33. So that's when the rejection region will be this area. This region will be rejection region. Okay, so now go back to the previous slide and look at the test statistics. So what is test statistics? Negative 2.83. So Z0 is, Z0 or Z observed is negative 2.83. So on the normal curve, on the x-axis of the normal curve, so where is the test statistics? Is it in the rejection region or outside the rejection region? So what do you think? If test statistics is in the rejection region, we'll reject the null, otherwise we'll fail to reject the null. So do we reject the? Okay, so why did we get negative? Yeah, good question. So if we go back to the previous slide, then you can see we calculated it, right? We calculated the test statistics here. Z0. X bar minus mu 0 is 31, which came from here, and sigma is 8, n is 32. So we simplified this one, and the simplified value is negative 2.83. Yeah, very good question. So now we have Z observed, or test statistics is negative 2.83. So where does negative 2.83 fall? It is in the rejection region or outside the rejection region? So what do you think? Should we reject null hypothesis or fail to reject? Anyone? Yeah, we reject the null hypothesis, right? That's correct, because negative 2.83 is on the left side of negative 2.33. So it should be somewhere here. So that's mean we reject null. Yeah. So since we reject the null hypothesis, we have to interpret the results in terms based on our decision. So when we reject the null hypothesis, so in this case, the interpretation should be like this. Okay, so let me write it on the next page. Okay, so how do we interpret this? So let's go back to the question. So we had the mu is equal, in null hypothesis, the mu is 31. And in alternative, the mu is less than 31. So that's mean, since we rejected the null, so that's mean we are favoring the alternative hypothesis. So our data, we have sufficient evidence that we are supporting the alternative hypothesis. So the interpretation should be like this. You should always report the level of significance. So at 1% level of significance, the data, because we calculated the test statistics based on our data. So that's when the data provide sufficient evidence to reject the null, or you can say to reject H0, or you can say to evidence that the population mean is less than 31. So we are rejecting null means we are supporting the in favor, we are rejecting null in favor of alternative. So that's when we are supporting the alternative. The data is supporting the alternative. So when you will write the interpretation, you should always mention the level of significance. So that's mean at 1% level of significance, the data provides sufficient evidence to reject null, or the data provides sufficient evidence that the population mean is less than 31, which was our alternative hypothesis. Do you have any question? Okay. If you do not have any question, let's move to the next example. A sample mean, sample size, and population standard deviation are provided below. Use one mean Z test to perform the required hypothesis test at 1% level of significance level. So here actually we are doing the same thing, but we have different sample size and the sample mean is also different. So here the sample mean is X bar is 29 and the sample size N is 37 and sigma is 4. So the first step is we need to step 1. So I'm writing step by step so that you can easily follow it. Okay. So the first one is you need to write the hypothesis. The alternative is mu less than 31. So this is also left tail test. So step 2 is you need to determine the alpha value. So alpha value is given. So this is 1%. Sorry, 1%. So that's mean alpha is 0.01. So this is our alpha value. So step 3 is calculate the test statistics. So you need to calculate the z observed, which is X bar minus mu 0 sigma over square root of n. So X bar is 29, mu 0 is 31, sigma is 4 over square root of 37. So if you simplify this one, then it will be negative 3.04. So this is our test statistics, z observed. So first step, we wrote the hypothesis, the null hypothesis and alternative hypothesis. So here mu 0 is equal 31. In step 2, we determine the level of significance or alpha value, which is 0.01. In step 3, we calculated the test statistic, which is z observed z0 is equal X bar minus mu 0 divided by sigma over square root of n. So we plugged in all the numbers. X bar is 29, mu 0 is 31, and sigma is 4, n is 37. So 4 over square root of 37. So if you simplify this one, then it will be negative 3.04. Okay, so we will use, here we'll use p-value approach. So that's mean you need to find the p-value. So to find the p-value, our test statistics is negative 3.04. So since this is a step 4, since this is left tail test, so the p-value is z less than z0. So that's mean probability of z less than negative 3.04. Okay, so in the z table, you need to look at negative 3.04. So if you look at negative 3.04, then you will get the p-value or probability. So the p-value is 0.0012. So if you look at the z table, then you will get 0.0012. So this is the p-value. Yeah, this is very small p-value, right? 0.0012. Okay, so step 5 will make our decision. So step 5, we know the alpha value, which is 0.01, and we know the p-value, right? The p-value is 0.0012. So here the p-value is less than alpha value. So we can write p-value is less than alpha, right? So what should be our decision? So we reject null or fail to reject null? What do you think? So should we reject null in this case or fail to reject null? Anyone? Yes, we reject null hypothesis, right? Because the p-value is less than the alpha value. Here the p-value is less than alpha value. So our decision should be reject the null hypothesis. Okay, since we reject the null hypothesis, now we need to write the interpretation. So step 6 is interpretation. So you need to always report the level of significance. So that's mean at 1% level of significance, the data provide sufficient evidence that the population mean is less than 31. Okay, so when you reject null, so you always write the interpretation like this. First, you need to report the level of significance at 1% level of significance. Then you will say that data, if you reject, then you will say the data provides sufficient evidence. But if you fail to reject, then you will say that data doesn't provide sufficient evidence. And then you will write the alternative. The alternative is mu is less than 31. So since we rejected the null here, then we will say the data provides sufficient evidence that the alternative is the population mean is less than 31. So that's how you will write the interpretation. Okay, do you have any question? Okay, thank you. So we'll go over some more examples. So we went over the left tail test. Now we'll go over right tail test. So a sample mean, sample size, and population standard deviation are provided below. Use one mean z-test to perform the required hypothesis tests and 1% level of significance. So here also the level of significance is 1%. So the step 1 is we need to write the hypothesis. So first write null and alternative. Null is mu is equal 25 and alternative is mu greater than 25. So for left tail test, it was less than. Now we have greater than. That's when this is right tail test. So step 2 is determine the level of significance. But here the level of significance is given, which is 1%. So that's mean alpha is 0.01. Then step 3, calculate the test statistics. So Z0 or Z observed is X bar minus, so here mu 0 is 25, right? The hypothesized value. Mu 0 sigma over square root of n. So here sigma is 8. Okay, now the question is, okay, you can ask me, here the sample size n is 12, right? Which is very small sample size, which is a small sample size. So now the question is, we do not know the population distribution, right? So up to this, we do not have any information about the population distribution. So why we are using z-test? Because it is given that we have to find the one mean z-test. So that's mean we are assuming that the population distribution is normal distribution in this case. So if we do not have this assumption, then we cannot use z-test in this case because the sample size n is 12 here. So which is very small sample size. But here we have that, since we are asked to find the one mean z-test, so that's mean we have the assumption that the population distribution is normal distribution. Okay, so let's calculate the test statistics. X bar is 33 minus 25. Sigma is 8 over a square root of 12. So if you simplify this one, you will get 3.46. Okay, so we'll use the critical value approach, or you can also use p-value approach. So in this case, we'll use the critical value approach. Okay, so step 4, find the critical value. So look at the alpha value, which is 0.01. And since this is right tail test, so the critical value is Z alpha. Which is 2.33. You will get this value from the Z table for alpha equals to 0.01. So if you look at the probability 0.01, you will get the Z score, which is 2.33. Actually, if you look at 0.01, you will get negative 2.33. But since this is right tail test, so we'll consider the positive value because our critical value will be on the right side here. So it is positive value. So it is 2.33. And this region is the rejection region. The right side of on the right side of 2.33. So step 5, we have the test statistics from the previous slide. So if you go back to the previous slide, you'll see that the test statistic is 3.46. So Z observed or Z0 is 3.46. So we have the test statistics is 3.46 and the critical value is 2.33. So 3.46 is somewhere here, right? So it is in the rejection region. So our decision will be then reject the null hypothesis. Reject H0. So what was the null hypothesis? The null hypothesis was mu is equals to 25. So we are rejecting this one. That's mean the data is supporting the alternatives. That's mean mu is greater than 25. The population mean is actually greater than 25. So our interpretation will be then. So now we need to write the interpretation of the results. So we have to, in the interpretation first, we have to mention the level of significance. So this is the step 6. So at 1% level of significance, the data provide sufficient evidence that the alternative is the population mean is less than 25. Mu is less than 25. That's when the population mean is less than 25. So this is the interpretation of the results. Do you have any question? So whenever you will perform the hypothesis test, you need to follow these 6 steps. So the first one is write the hypothesis, then determine the alpha value, then calculate the test statistics. Then step 4, Yeah, find the critical value or p-value. And step 5, make your decision. And the final step is interpret the results. And this is the most important. Most important means actually people, it will look at this one, your final conclusion or final interpretation. Yeah. Okay, so this is also right tail test. And here we'll use the p-value approach. So we already have the test statistics. So step 1, you need to write the hypothesis. We have the hypothesis. Step 2, you need to determine the alpha value. So alpha is 5%, which is 0.05. And you need to find the test statistics, which is z observed, x bar minus mu 0, sigma over square root of n. X bar is 40 here, n is 14, and sigma is 6. So if you simplify this one, and the hypothesis value mu 0 is 34. So if you simplify, plug in all the values and simplify, then you will get 3.74, the test statistics. Then you need to find the p-value. The p-value is, since this is right tail test, so the p-value will be z greater than 3.74. Okay, so if you look at 3.74, this is 3.7 and 4 is here. So this value is 0.9999. But the thing is that, okay, this is 3.74. So if you look at this number, you will get this area, which is 0.9999. But we are looking for the area on the right side. So that's mean it will be then 1 minus 0.9999. So it will be then 0.0001. So the p-value is 0.0001, which is very, very small. And compared to the alpha value, this is very small value. P-value is very small. So that's mean we reject the null hypothesis. So in this case, we reject the null hypothesis. And then the interpretation will be then at 5% level of significance, the data provides sufficient evidence that the population mean is greater than 34. Do you have any question? Okay, so we went over the left tail test, right tail test, and now we'll go over two tail test. Okay, so I'll also go step by step. So here x bar is 23, n is 28, and sigma is 9. So first thing is you need to write the hypothesis. So step 1. Write the null hypothesis, which is mu is equals to 22. And alternative is mu not equal 22. So that's when this is two-tailed test. So the alternative is mu is different from a specific value or particular value 22. We want to test this. So that's mean this is two-tailed test. So the next step is determine the alpha value. So the alpha value is given here, which is 10%. So alpha is 10%. So that's mean alpha is 0.1. So this is our alpha value. So the level of significance. The third step is we need to calculate the test statistics. Okay, so for any hypothesis test, left tail, right tail, or two-tail test, these three steps are same. Same means first you will write the hypothesis, then determine the alpha value. Then step 3, you will calculate the test statistics. This is exactly, you will be using the same formula for any test, like for right tail or left tail, it doesn't matter. Yeah, the same formula. The difference is step 4, when you will find the critical value. For left tail test, it will be negative z alpha. For right tail, it is z alpha, and for two tail, it is positive and negative Z alpha over 2. So for two tail, we'll have two critical values. Okay, so now plug in all the numbers. X bar is 23, mu 0 is 22, and sigma is 9 over square root of 28. The test statistics is 0.59. So 0.59. So this is our test statistics. Okay, do you have any question? Okay. The next thing is find the critical value. So this is different from other two type of tests like left tail and right tail. So step 4, critical values. So critical values, we will have two critical values here because this is two tail test. Plus minus Z alpha over 2, where alpha is 0.1. So alpha over 2 is 0.05. So that's mean plus minus Z 0.05. So you have to look at 0.05. You will get a negative number. So that's mean you have to consider two numbers. One is negative and the other one is positive. The critical values is in this case is plus minus 1.645. Because if you look at in the Z table, if you look at 0.05, it will be in the middle of two numbers for two ZS. In between two ZS scores, you will get the ZS score for 0.05. So the ZS score for 0.05 is between 1.64 and 1.65, and the average is 1.645. Yeah. So I already showed you this in the previous class. So how to find the ZS score from the Z table. So this is plus minus 1.645. So we have two critical values here. So now draw the normal curve. This is negative 1.645. And this is positive 1.645. So the rejection region is this one and this one. Okay, so now locate the test statistics on the normal curve. So what was the test statistics? It was 0.59. Okay. So the middle value is 0. So 0.59 is somewhere here. So this is 0.59, right? This is the test statistics. This is our Z observed or test statistics. So this is our we have two rejection regions here. One is this one, the other one is on the right side, this one. Yeah, but the test statistics is not in either this one or this one. So it is in the non-rejection region, right? 0.59 is in the non-rejection region. So that's mean we fail to reject now. So step 5, we fail to reject null hypothesis, right? Because the test statistic is not in the rejection region. Do you have any question? Okay, so now if you do not have any question, I'll write the interpretation of the results. So step 6. Interpretation of the result. So first you need to write the level of significance. So the level of significance was 10%. At 10% level of significance, the data, since we failed to reject null, so that's mean the data doesn't provide sufficient evidence to support alternative. Provide sufficient evidence that the alternative is the population mean is different from 25, right? Sorry, 25 or 22? 22, yeah. So the population mean is different from mu is not equal 22. So that's when the population mean is different from 22. So the data doesn't provide sufficient evidence that, or to conclude that the population mean is different from 22. Do you have any question? Okay, thank you. Okay, so if you do not have any question, then we'll go over one more example. And this is also two-tailed test, but we'll use the p-value approach. So I will show you how to calculate how to find the p-value for two-tailed test. Okay, so here we have X bar is 24, N is 27, sigma is 8. So step 1 is write the alternative and null. So mu is 27, mu is different from 27. So here mu 0 is 27, right? So step 2 is determine the level of significance. So this is alpha, this is 1%, so that's mean 0.01. So step 3 is calculate the test statistics, Z0. So X bar is 24 minus 27, sigma is 8 over square root of 27. So if you simplify this one, then you'll get negative 1.95. So this is negative 1.95. Do you have any question? Okay, so if you do not have any question, then now we'll calculate the p-value. So step 4. So since this is two-tailed test, and the test statistics is negative 1.95. So for two-tailed test, the test p-value is z greater than absolute value of z0 times 2. So this is the p-value actually for two-tailed test. Why this is the p-value? Why 2 times of this? Because our rejection region, this is negative z alpha over 2, and this is z alpha over 2. Okay, so why do we consider absolute value? So the first question is, why do we consider absolute value? Actually, this means we consider absolute value because z0 could be positive or negative, right? So if we do not consider absolute value, so here in this case, z is negative, z0 is negative. So if we find the probability z greater than z0, this is negative. So it will be always greater than 0.5, but this is not true. That's not the p-value. That's not our correct p-value. So for two-tailed test, you will consider the absolute value of z0 and z greater than this one. So now the question is, why did we multiply with 2? Okay. So we'll compare the p-value with alpha, right? But here we are just finding the p-value on the right tail, right? Z greater than absolute value of Z0. So when you consider absolute value, it is positive value. So that's mean Z greater than this one. That's mean we are calculating the p-value on the right tail. So what is the area of the right tail? So this is alpha over 2. And for example, if our test statistics is somewhere here, then that will be the p-value. So what we are doing here, we are calculating the p-value on the right tail. That's why we are multiplying with 2, because the p-value, and we are comparing with alpha over 2. Okay, here the thing is that if you compare this p-value with alpha over 2, that's fine. Then you do not need to multiply with 2. But if you want to compare with alpha, then what will happen? You will multiply with 2 here and 2 here, right? It will be cancelled out. So that's mean it will be 2 times this probability, right? 2 times this probability. That's mean the probability of Z greater than this one. And here we will have alpha. Then you can compare with alpha. Okay, so here the idea is, if you do not multiply with 2, if you do not multiply this one with 2, then you can compare with alpha over 2. That will be absolutely fine. But if you multiply with 2, then you have to compare with alpha. Is it clear, or do you have any question? Yeah, for two-tailed test, it is little confusing, but once you get the clear idea, then yeah. So what chapter will be covered one year quiz on Tuesday? Okay, so we'll just cover chapter 9. It will just cover chapter 9. And you will have only 2 questions. Okay, I will send you an email about this. Okay. You're welcome. So is it clear how did we calculate the p-value for two-tailed test? Yeah, I know that it is little confusing, but if you understand this one clearly, then yeah, it will not be a problem. Yeah. Do you have any question? Yes, sure. I can go back to the previous slide. Sure. Yeah, whenever you are done with this one, please let me know. Okay, thank you. Yeah. So now we'll calculate the p-value. So our test statistics was negative 1.95, right? It was negative 1.95. So we'll calculate the p-value. So p-value is Z greater than absolute value of Z0. So, and times 2. This is our p-value. So then it will be 2 times probability of Z greater than absolute value of negative 1.95. That's been 2 times probability of Z greater than 1.95. So look at 1.95. So we have here negative 1.95. So this is 1.9 and 5 is here. So it will be then this one. 0.0256. Okay, so we are looking at the negative number. It will give us this area, but we need the area on the right side. We need actually this one, this area, but they are same. So that's why if you just look at the negative number, that would be fine. This is 0.0256. So that's when it will be 2 times 0.0256. So it will be then 0.0512. So this is the p-value. Yeah, sure. The absolute value of z0. So absolute value is an operator. So if you consider the absolute value of -2, then it will be 2. So if you consider absolute value of z0 here, which is absolute value of -1.95, that will become 1.95. Okay. Yeah. So is that answer your question, or your question was why did we consider absolute value of z0? Yeah, for two-tailed test. Okay, yeah, very good question. Yeah, let me explain it again. Okay, so here we have z0 is -1.95, right? So for two-tailed test, what we are doing here, so we have, this is our negative z alpha over 2, and this is z alpha over 2, right? So that's when the area on the right side is alpha over 2, and this area is alpha over 2, right? Okay, so now we want to find the p-value for two-tailed test. So if you find the for one tail, how did we calculate the p-value? For right tail, we calculated z greater than z0, right? This is for right tail. Okay. For left tail, we just calculated this, right? For left tail. Left tail. Okay. So now the problem is for two-tailed test, because for two-tailed test, the test statistics, it could be negative or positive, right? Okay. So the test statistics could be negative or positive. So if since this is negative, and if you calculate this probability z greater than z0, that's mean -1.95, then what will happen? -1.95 will be somewhere here, right? Okay, so if you calculate z greater than, because you do not know whether your test statistics is positive or negative, we do not know, right? So here this is negative. Now if you calculate this probability z greater than -1.95, then it will be this area, and that is absolutely greater than 0.5, right? But the problem is this is not the actual p-value, because our test statistics could be, for rejection, it could be somewhere here, and it could be also somewhere here. So when it is negative, actually we need to calculate the probability on the left side. So for two-tailed test, we have rejection region on the left side and also on the right side. So when this value is negative, actually we were supposed to calculate the probability, and that should be the area on the left side of this number, but we do not know whether z0 is negative or positive. So that's why to be on the safe side, we always consider absolute value. So if you consider absolute value, that's mean it is sure that it is on the right side, right? So that's mean you will be calculating the probability on the right tail. So that's mean we always calculate the probability p of z greater than, we can use this sign, z greater than absolute value of z0. Okay, or if you know the test statistics, even without doing absolute value, you can calculate it. So since we know this is negative, so you can just calculate z less than z0 and 2 times of this. But when it will be positive, then you have to calculate z greater than z0 times 2. So that's mean you will be changing this sign based on this sign. But we do not, if you do not want to do this, if you want to be on the safe side, then you can always consider the absolute value and greater than sign. Then it will be actually consistent. Otherwise, you have to switch this sign based on the sign of the test statistics. Is that answer your question? Okay, thank you. Yeah, I know that the calculating the p-value for two-tailed test is little confusing, but once you get it, then you'll be fine. Okay, so we calculated the p-value and we found that the p-value is 0.0512. So what was the level of significance? So let's go back to the previous slide. One more back. So the significance level was 1%. That's when 0.01. And the p-value is 0.0512. So that's when the p-value is greater than alpha, right? So p-value is greater than alpha. So that's when we fail to reject null. So in this case, we fail to reject null. So our interpretation will be at 1% level of significance, the data doesn't provide sufficient evidence to conclude that the population mean is different from, so what was the value, 27? Yeah, 27 is not different from 27. Do you have any question? Okay, so we have two more examples, but I'll just go over one example from here. So this is for left tail test. This one is left tail, and okay, and this one is okay. So let's go over this one. The recommended dietary allowance RDA of iron for adult female is 18 milligrams per day. The given iron intakes were obtained for 45 random adult females at the 5% level of significance. Do the data suggest that the adult females are on average getting less the RDA of 18 milligram of iron? So we want to test whether the adult females on average getting less than the RDA of 18 milligram of iron. So assume that the population standard deviation is 4.7 milligram and preliminary indicate the applying z-test. So we have to, they said that z-test is reasonable. So that's mean the data is close to normal distribution. So we can use z-test. So that's fine. So now step one, we need to write the hypothesis. So what should be the null hypothesis here? Mu is equal. So which value we should consider in this case? 14.77 or 18? So what should be the null? What do you think? Mu is 18 or 14.77? So we want to test we want to test whether mu is less than 18 milligram, right? So that's mean the hypothesis value is 18. So what is the alternative here? We want to test whether the female are getting less than the RDA of 18 milligram of iron. So that's when we want to test whether mu is less than 18 or not, right? So this is our hypothesis. So that's mean this is left tail test. So step two, you have to determine the alpha value, level of significance. So the level of significance is 5%. So this is 5%. So that's mean this is 0.05. And the population standard deviation sigma is 4.7. We have to calculate the test statistics. Z0 is x bar minus mu 0 sigma over square root of n. The sample size is n equals to 45. So x bar is 14.77. 14.77 minus mu 0 is 18. Sigma is 4.7 over square root of 45. So if you simplify this one, then it will be negative 5.43. So if you simplify this one, it will be negative 5.43. Okay, so next step is, so we'll use the critical value approach. So find the critical value. So negative Z alpha. So that's mean negative Z alpha is 5% level of significance. So alpha is 0.05. Then it will be negative 1.65 or 1.645. Actually, it will be negative 1.645. So we have the critical value. So now step 5, we'll make our decision. So draw the normal curve. It's always better to draw the normal curve. So since this is left tail test, the rejection region will be on the left side, which is negative 1.645. And what is the test statistics? The observed we found in the previous slide, which is negative 5.43. So write down this one, negative 5.43, and it should be somewhere here. So it is in the rejection region. So our decision will be reject the null hypothesis. So we'll reject the null. So that's when the interpretation will be at 5% level of significance. The data provide sufficient evidence that the average intake of the iron for adult women is less than 18 milligram. Do you have any question? Okay, so we are going over too many examples, so many examples, so that it's become more clear to you, so that you do not have any confusion in any step of the hypothesis testing. Okay, suppose that the mean height of women aged 20 years or older in a certain country, the height of, okay. So 20 years women height is, average height is 62.7 inches. 100 randomly selected women in a certain city had a mean height of 61.5 inches. At the 10% level of significance, do the data provide sufficient evidence to conclude that the mean height of the women in the city differs from the national mean? So the national mean is 62.7. And in a city, from a sample, we found that the average height of the women are 61.5 inches. So now we want to see whether the average height of the women in that city differs from the national mean. So we want to see whether the mean mu is different from. So what is actually mu here? The population mean. So what is the population here? Anyone? All the individuals we are interested about. So what is the population here? So we are interested about the women who are 20 years old in that certain city, right? Because we are interested about the average height. Yeah, we want to, yeah, 62.7 is national mean, but we want to see that whether mu is different from this or not. Actually here, the mu is not 62.7. This is actually the national mean, right? The national average. But we are interested about the city. Yeah, this value is the hypothesis value. This is actually mu 0, which is mu 0 is 62.7. But here actually we are interested about the women who are 20 years old and living in that city. So That's our population. So we are interested about the mean of this population. So mu will be actually the average height of the women who are 20 years old and living in that certain city. So that will be actually our mu. So now we want to test whether this mu is equal the national mean. So what is the national mean? Which is 62.7. So we want to see whether this mu is different from this value or not. So we want to see this. So that's why this is two-tailed test, right? This is two-tailed test. So what is the sample mean? Sample mean X bar is 61.5. Yeah, this is 61.5. Thank you. This is the sample mean. Yeah, that is 61.5. And 62.7 is the hypothesis value. Okay, so what is the sigma? Sigma is the population standard deviation, which is 3.8. Sigma is 3.8. And the sample size n is so what is the sample size? 100 randomly. So this is the sample size, 100, 100. This is the sample size. So now we have all the informations, right? We have mu0, we have sigma, we have n, we have X bar. We can calculate the test statistics. This is two-tailed test. So we'll have two critical values, negative plus minus z alpha by 2, and which is plus minus 1.645. And our test statistics is negative 3.16. Okay. So this is negative 1.645. And this is 1.645. So this is our rejection region. But negative 3.16 is somewhere here. So it is in the rejection region, right? So that's mean we reject the null hypothesis. So since we reject the null hypothesis, that's mean our conclusion should be at 1% level of, 10% level of significance. The population mean or the average height of women who are 20 years old and living in that city is different from the national mean. That's when it's different from 62.7. Do you have any question? Okay, so we have one more section left from this chapter, section 9.3. And after that, we'll have two more chapters, chapter 10 and chapter 11. And then we'll be done with the syllabus. Okay. So I'll try to give you some idea about this section. So this is also about hypothesis test for one population mean. So hypothesis test for one population mean when sigma is unknown. Okay, so what is the difference between the hypothesis test in section 9.5 and the hypothesis test in section 9.4? So what is the basic difference, or what is the main difference between these two hypothesis tests? Do you see any difference? In section 9.4, we did hypothesis test for one population mean, right? And here we are doing the same thing. We are doing hypothesis test for one population mean. But what is the difference? Anyone? Do you see any difference? Or we are doing the same thing? Yeah, there should have some difference, right? Because this this is a different section. So the main difference is in the previous section, sigma was known. And here sigma is unknown. That is the main difference. Now, what is the problem if sigma is unknown? If sigma is unknown, the problem is when sigma is known, we have the value of sigma. When sigma is unknown, when it is known, we know the value of sigma, right? When it is unknown, we do not know the value of sigma. So in this case, the test statistics was x bar minus mu 0 sigma over square root of n. Now the question is, can we use the same formula to calculate the test statistics when sigma is unknown? What do you think? Can we use the same formula when sigma is unknown? Anyone? Yeah, that's correct. Yeah, your guess is, yeah, you did the correct guess. Yeah. We cannot, because sigma is unknown, right? We do not know the value of sigma. So how can we calculate? Yeah, we have to find the sigma first. Yeah, that's correct. But how do we find the sigma first? Sigma. Do you remember? Okay, so when we do not know the value of mu, what did we do? We had actually one chapter or two chapters about this. So when we do not know the value of mu, yes, that's correct. We'll find the standard deviation. So what is standard deviation? Sample standard deviation. Yeah, that's correct. So we'll find the sample standard deviation. So when we do not know the value of mu, we use x bar, sample mean, right? Then we also, this is called point estimate. We also did interval estimate for mu. Okay, but for sigma we didn't do any interval estimate, but we have point estimate. So when sigma is unknown, we'll use the sample standard deviation S. Then in this case, you have to use S over square root of n. Okay, now the problem is when we are using S instead of sigma, we cannot use this test anymore. Why? Because S is also the function of x, which is random variable, and x bar itself is random variable. Now, in the previous case, we had only one random variable. Now we have this one random and this one also random. So that's why we have ratio of two randomness. So that's mean it doesn't follow normal distribution. It follows some other distribution, which is called the t distribution. We already discussed this one when we constructed the confidence interval. If you remember, so when sigma is known, we used z interval. When sigma is unknown, we use t interval. So similarly for hypothesis test, when sigma is known and sample size is large or the population distribution is normal, you can use z test. But when sigma is unknown, we have to use t test. So for t-test to find the critical value, so for z-test to find the critical value, we had to just know the alpha value, right? Then we find z alpha, negative z alpha, positive z alpha, plus minus z alpha over 2. But for t-test we need to know also the degrees of freedom, df, degrees of freedom, which is called df, which is n minus 1. Yeah, this is called, you also need to know this value. Okay, so this is for left tail and right tail test. So for left tail test, the critical value, if you find the critical value, so then the left side, this one will be the rejection region. And if this is our test statistics, then on the left side, it will be the p-value. And to find this one, actually this distribution is when degrees of freedom is 11. But if you change the degrees of freedom, that's mean if here n was 12. Now if n is 25, then the degrees of freedom df will be 24. Then you will not have this same distribution. It will be something different. It will be like this. Like this. The distribution will be like this. Okay, so when the degrees of freedom increases, it actually becomes close to normal. When the degrees of freedom is large, that's when sample size is large, it's become very close to normal. Okay, anyway, And similarly for two-tailed test, we'll have two critical values. Yeah, the idea is exactly same as z-test. The only difference is, so you will be using t-table to find the critical value and p-value in this case. And in previous case, we used z-table or z-distribution to find the critical value and p-value. Sorry, critical value and yes, p-value. Okay, so this test is also for one mean. That's mean one population mean. And this is called one mean t-test. Okay, so the purpose is same to perform a hypothesis test for a population mean. And for z-test, we did the same thing. We did a hypothesis test for population mean. So for z-test, we had three assumptions. And similarly for t-test, we have three assumptions. The first one is same, exactly same, simple random sample. We had the same assumption in z-test, simple random sample. And the second one is normal population or large sample. So we had the same assumption in previous case. The only difference is here sigma is unknown. And in the previous one, in the z-test, sigma was known. That is the only difference. Okay, so steps are similar. First one is you need to write the hypothesis. If it is not equal, the alternative, then it is two-tailed. If it is less than, then it is one-tailed or left-tailed. If it is greater than, then it is right-tailed test. Step 2, decide is the same. You have to determine the alpha value. Then you will compute the test statistics. In previous case, it was z observed, x bar minus mu 0, sigma over square root of n. Now it is t observed or t0, x bar minus mu 0, s over square root of n. Previously, it was population standard deviation sigma. Now it is sample standard deviation s. That is the only difference. Okay, so step 4 is similar. We have to find the critical value. So for two-tail, it will be t plus minus alpha over 2. For one-tail, it is negative t alpha. For right tail, it is t alpha. And to find this one, you need to know the degrees of freedom, df. And degrees of freedom is n minus 1. Similarly, you will find the p-value. So for one tail, the p-value will be probability of t less than t0. For left tail, for right tail, it will be t greater than t0. And for two tail, it will be 2 times probability of t greater than absolute value of t0. Yeah. It's similar, actually, similar to the z-test. The only difference is in z-test, we use z distribution. Now we are using t distribution. Okay, step 5. For a critical value approach, you will compare the critical value and test statistics. And for p-value, you will compare the p-value and alpha value. Then you will make your decision. Okay, and in the final step, you have to write the interpretation in terms of the alternative hypothesis. Okay, I think we do not have enough time to go over example. So in the next class, we'll go over a couple of examples, and after that, I will give you the quiz. And your next quiz will be on chapter 9, and you will have total 2 problems, and I'll give you around 25 to 30 minutes. I think I should give you 30 minutes for the next quiz. And it will be the last 30 minutes of the next class. Do you have any question?